Hi everyone, you are welcome back to another interesting question. We are asked to calculate the area in green, that is this triangle. We can see the length of this side is 14 meters, while this line segment has its length to be 8 meters, and this is 6 meters. We see this angle is 60 degrees, and this is also 60 degrees. This side and this side are parallel. So how can we solve this? How can we calculate the area of this triangle? Well, it is very simple. We'll start by labeling the points P, Q, R, S, and T. So we are to calculate the area of this triangle QRT. We first look at this quadrilateral. This side and this are parallel, and that makes it a trapezium. The length of this side is 14 meters, and here its length is a summation of 18 meters and this 6 meters, that's 14 meters. So this side and this side are congruent, and that makes it an isosceles trapezium. We know in an isosceles trapezium, each pair of base angles are congruent. That is, this angle and this are equal, and this are also equal. So since this is 60 degrees, this must also be 60 degrees. We write it out, angle QTS equal to 60 degrees, while here, if we let this be x, this must also be x. We know the summation of angles in a quadrilateral is 360 degrees. That is, this angle, this, and this, if we sum them up, they'll be equal to 360 degrees. So x plus 60 degrees plus 60 degrees equal to 360. X plus x is 2x. 60 plus 60 is 120. Take 120 to the right. 360 degrees minus 120 degrees is 240 degrees. Divide both sides of the equation by 2. Here 2 cancels 2, while here 240 divided by 2 is 120. So x equal to 120. That is, this angle and this are 120 degrees. We also write it out here. Angle PQT equal to 120 degrees. To calculate the area of this triangle, we first assume the length of this side to be x and this y. We see the size of this angle is 60 degrees. So we use the formula area of triangle equal to 1 over 2 AB sine C. A and B are representing two sides of the triangle, and angle C is the angle between them. So here, if we take this side as A and this B, this must be angle C. So A equal to x, B equal to y, and angle C equal to 60 degrees. Put it here. Sine 60 degrees is root 3 over 2. 1 over 2 times x times y times root 3 over 2 is root 3xy over 4. So area of triangle QRT equal to root 3xy over 4. We keep it aside. Come here. From this vertex Q, construct a line which will be at an angle 60 degrees with this side to this line. Recall this angle, we have its value here to be 60 degrees as well. So to this triangle, since two of its angles are 60 degrees each, based on the rule that the summation of angles in a triangle is 180 degrees, this angle must be 180 degrees minus 60 degrees minus 60 degrees, which is 60 degrees. Now this makes the triangle an equilateral triangle, and in an equilateral triangle, all the sides are equal. That is, this side, this, and this are congruent. So since this is 14 meters, this and this each must also be 14 meters. Call this point V, then write out the length of line QV. So line QV equal to 14 meters. Here we see this angle QVT and this QRT both have their sizes to be 60 degrees each. That is, they are congruent, and at the same time they are subtended by this same line QT. In a cycle, we know that a chord subtends the same angle to any point on the circumference of the cycle. So here, if we assume line QT to be a chord of the cycle, if we draw out the cycle, its circumference will definitely pass through this point R and this V. Okay, look at this angle and this. Both are subtended by this arc. That makes them congruent. So if we let this be H, this must also be H. Come here, draw a chord RV. Look at this angle and this angle as well. They both are subtended by this arc, and that makes them congruent. So since this is 60 degrees, this must also be 60 degrees. Now look at this quadrilateral QRTV. It has all its vertices lying on the circumference of the cycle. That makes it a cyclic quadrilateral. We assume the length of this side to be Z. Line QV, don't forget, we wrote it here. Now to this cyclic quadrilateral, we use the Ptolemy's theorem, which states that for a cyclic quadrilateral, the sum of the product of two pairs of opposite sides is equal to the product of its diagonals. That is, the summation of the product of this x and this 14 and that of this 14 and this z must be equal to the product of this y and the length of this line QV. So x times 14 plus 14 times z equal to y times 14. Here we factor out 14. So it is 14 into x plus z. This 14 cancels this 14. So y equal to x plus z. Keep it aside. Here, this line QV is at an angle 60 degrees with this side, and this line PS also at an angle 60 degrees with this side. That makes the two lines parallel. So here we see this line QR intersect them both. It will form alternate angles. That is, this angle and this are congruent. So since this is H, this must also be H. Now look at this triangle PQR. It has an angle 120 degrees and angle H. Same is for this triangle QRV. This angle of it is 120 degrees divided into 260 degrees. It also has an angle H. That makes the two triangles similar. So if we take the ratio of their sides, this side facing angle 120 degrees divided by this must be equal to this side QV. Its length is here 14 meters divided by this side x. So x over 8 equal to 14 over x. Cross multiply. X times x is x squared, and 8 times 14 is 112. Take the square root of both sides. Here square root of x squared is x, while here square root of 112 is 4 root 7. So x equal to 4 root 7 meters. Substitute it here. Now y equal to 4 root 7 meters plus z. What is the value of z? We don't know. But to this triangle QRV, we can use the cosine rule, by which for any triangle ABC, c squared equal to a squared plus b squared minus 2ab cos c. Here, if we let this be a and this b, this must be c, and this angle will be angle c. So x equal to 4 root 7 meters, b equal to z, c equal to 14, and angle c equal to 60 degrees plus 60 degrees, which is 120 degrees. Substitute them here. So 14 squared equal to 4 root 7 all squared plus z squared minus 2 times 4 root 7 times z times cos 120 degrees. 14 squared is 196. 4 root 7 all squared is 112. Here minus 2 times 4 root 7 times z is minus 8z root 7. Cos 120 degrees is minus 1 over 2 minus 8z root 7 times minus 1 over 2 is plus 4z root 7. Bring this 196 to the right. 112 minus 196 is minus 84. So z squared plus 4z root 7 minus 84 equal to 0. This is a quadratic equation. If you solve using the quadratic equation formula, you'll get z equal to 2 root 7 or z equal to minus 6 root 7. This is negative, hence it can't be the value of z. 4 root 7 meters plus 2 root 7 meters is 6 root 7 meters. Now we have x equal to 4 root 7 meters and y equal to 6 root 7 meters. Substitute it here. Root 3 times 4 root 7 times 6 root 7 over 4 is 42 root 3. So green area equal to 42 root 3 meters squared. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.